So in this video, we are going to apply the proof from the previous video that the angle at the center is twice the angle at the circumference standing on the same arc. And then we're going to go ahead with a couple more different proofs for angles in circles. Now, using that proof, we can say that because the angle at the circumference here is 54 degrees, the angle at the center is going to be 2 lots of that. So y is going to equal 108. And our reason is going to be that the angle at the center is twice the angle at the circumference standing on arc BC. Cool. Pretty straightforward now that we have done the proof and we understand it. Now, similar example here. We're given that the angle at the center is 94 degrees. We want to find the angle at the circumference. So it's going to be half of that angle at the center. So x is going to equal to 47 degrees. And the reason we're going to put the angle at the circumference is half the angle at the center standing on arc BC. Okay, so we are just applying this. There's no need to prove. We are just giving reasons for our answers. Now, going in with a few more circle theorems, we're going to prove that angles at the circumference standing on the same arc are equal. So here we're told that O is the center of the circle, and we want to prove that angle PSQ is equal to angle PRQ. Now, to do this, we are going to go back to that circle theorem that we've proven in the previous video. So we're going to say that just by drawing these extra dotted lines in, we now have an angle at the center. We have this angle POQ. Now, what do we remember about this relationship? Well, we remember that, let's just let angle PRQ RQ be x. Now, we know that angle POQ equals 2x. That is the circle theorem that we have just dealt with. So we know that the angle at the center is twice the angle at the circumference standing on arc PQ. Now, we can say that this guy then is going to be 2x, but notice that all of these are basically standing on that same arc PQ, right? So we can now make a relationship between angle POQ and PSQ. We can say that angle PSQ equals to just x, because the angle at the circumference is half the angle at the center standing on arc PQ. So we've now just used this angle at the center to make a relationship between these two angles. So because they both equal to x, we can therefore say that angle PSQ equals to angle PRQ. Okay, moving on. Now we can find unknowns using this theorem. So here, just by looking at it, we've just proven it. X equals to 41 degrees. And we're going to give our reason. Circumference on the same arc PQ are equal. And there we have it. Our x equals to 41 degrees. Now, another circle theorem we'll just talk about briefly is that equal arcs subtend equal angles at the circumference. So with this, if the arc is the same length, equal arcs, even though the angle is at the circumference, they subtend equal angles at the circumference. So here, we're not actually proving anything. We're just finding the value of x. So x equals to 37 degrees. And we are saying that equal arcs subtend angles at the circumference. Cool. All right, moving on. Now, we also know that equal angles at the circumference stand on equal arcs. So, given that both of these angles equal 25 degrees, we can say that PQ, our arc PQ, I'll specify that. Our arc PQ equals to 8 centimeters. And our reason is equal angles at the circumference subtend